This is a walkthrough of Problem 2 on Practice Exam 2 of Module 8 in the book Problem Solving Guide for Mechanics and Thermodynamics. A wooden wheel has a mass of 30 kilograms and a diameter of 1 meter. 1 meter across, mass 30 kilograms. The rim has a mass of 18 kilograms, and each of the 4 spokes has a mass of 3 kilograms. That's a total of 30 kilograms. The wheel is mounted on an axle and turns without friction. So there's an axle going right through the middle, spins around without friction. A, what is the moment of inertia of the wheel about its axis? A rope is wound around the resting wheel. The tension is 10 newtons applied to it over a distance of 2 meters. What is the kinetic energy of the wheel? And part C, what is the angular speed of the wheel at this point? Okay, there's a couple of ways to get the moment of inertia. We can think about it as 4 spokes, each length half a meter. Remember, the diameter is 1 meter. And these 4 spokes are rotating about the end. Or we can think about it as 2 rods, each length 1 meter, rotating about their middles. Which one do you want to do? Let's do both. Okay, so we have 4 rods rotating about their end. Each of them is 3 kilograms, it says. Each of the 4 spokes has a mass of 3 kilograms. The moment of inertia of a rod about an end is 1/3 ml squared. So we have, there's 4 spokes. Each is 1/3 ml squared. 3 kilograms each a half a meter long, and we get 1. There's a 4. Half squared is 1/4. There's a 3, and there's a 1/3. So it's 1 kilogram meter squared. Now let's do 2 rods rotating about their centers. Each of the rods are a meter long. Each weighs 6 kilograms. So we have 2 rods. The moment of inertia of a rod about the center is 1/12 ml squared. So we plug in m 6 kilograms. The length is 1 meter. We have 6 times 2 in the top and a 12 in the bottom. That's also 1. Either way you do it, you get 1 kilogram meter squared for the moment of inertia of that wheel about its middle. Oh, wait a minute. Those are just the spokes. We got to put the rim in. Now, the rim is all r away, so that's just mr squared. So mr squared, 18 kilograms times a half a meter squared, that's 4.5. The spokes are only 1. So the total is 5.5 kilogram meters squared, and that's the answer to part A. Part B. Wind the rope around the wheel, exerts a force of 10 newtons for 2 meters. What's the kinetic energy of the wheel? Now, you got to think about this, and it should be pretty clear after you think about it for a while. A 10 Newton force for 2 meters. How much work is that? That's 20 joules. Where else can the energy possibly go? It's got to be in the rotational energy of the wheel. So I think it's just 20 joules. Yeah, 20 joules. Answer to part B is 20 joules, force times distance. Part C asks for the angular speed of the wheel. We know the kinetic energy is 20 joules. We know its moment of inertia. There's pure rotation. It's on an axle. It can't translate. So all of the 20 joules is in the rotational kinetic energy, and the kinetic energy is 1/2 I omega squared. The general formula for the kinetic energy of a rotating body is 1/2 I omega squared, and we calculated what I was, 5.5 kilogram meters squared, and we know the kinetic energy is 20 joules. There's the equation, 20 joules in rotational kinetic. We know the moment of inertia. We can calculate omega, 2.7 radians every second. A little bit less than 1 cycle per second. That thing's got a lot of moment of inertia. 30 kilograms is heavy. That's the answer to part 2, problem 2.